Hello students, today we will see how to measure the internal resistance R of a battery using potentiometer. For this, first we will see circuit arrangements. This is our potentiometer, a strong battery, the battery having EMF very much high as compared to this E. A rheostat and a key of this potentiometer makes its a driving circuit. It generates a constant current that flows across terminal A to B where a metallic wire is connected. A uniform metallic wire is connected and its resistance is proportional to the length of the wire. Suppose the whole length of this potentiometer wire is L. Usually it is from 5 to 10 meter. So we can write it here that AB is L meters in length. This creates a drop because of this current of the current flowing through this driving circuit. So it creates a drop, and suppose that drop is V naught. So we also know that drop is proportional to the resistance and it is proportional to the length. So we can conclude that V naught is proportional to length. Okay, and this is the whole length of the wire. Now we come to this circuit that is connected across our potentiometer. This is battery which is connected across terminal A and B. At terminal A, it is connected to this potentiometer terminal with a wire having negligible resistance. So no current will flow through this wire as resistance is 0. This terminal B is connected to metallic wire through a galvanometer. This is jockey of the galvanometer that slits on this metallic wire to create a contact so that we can measure the length where the deflection is 0. Wherever there will be a zero deflection, this potential will be same as this. So we can directly measure with the help of this length the potential of the circuit connected across it. Okay, and this is a known resistance along with a key. Now to find internal resistance of this battery, we have to consider two cases. First, when this switch is opened. First case, when switch or key, you can say. To find the internal resistance of the battery, we have to consider two cases. First, when this key is opened. Case 1, when this key is opened, and the next when it is closed. So when it is opened, this resistance is not part of our circuit. So this EMF we can calculate using this galvanometer. So with the help of this jockey, we will search a point where the deflection of this galvanometer is 0. Okay, this with the help of this jockey, suppose we got a point P where this deflection is 0. So at that point we can measure the length of this AP. Suppose it is small l, and as we know this potential is proportional to the length. So this here E. Since only this battery is connected, so its potential will be proportional to the length, that is L here. Here this length of metallic wire is L where deflection is 0. So with the help of these two, we can get a result that EMF of battery is nothing but small l divided by the total length of the wire multiplied by the voltage drop, total voltage drop because of this driving circuit across metallic wire. So we got a relation, and this is our first equation. we got by when our K is opened. Now close this switch. Our second case is when our plug key is closed. If we close this key, then this resistance becomes part of our circuit and a current will start flowing through because of this battery, and this current will flow through this resistance and will create a drop. Now this AB, across this AB there will be a drop, that is I multiplied by R. Drop across AB will be nothing but VA minus VB will be I multiplied by R, and you can write this I in terms of these battery EMF divided by the total resistance. This is our I multiplied by R. So this is nothing but voltage across AB terminal when switch is closed. Okay, so this VA minus VB is voltage drop across AB terminal when this switch is closed. Now we will again find the length of metallic wire for which deflection across galvanometer is 0. That will give us the potential in terms of length. So we will find the length, another length. Suppose using this jockey suppose using this jockey we got another point, that is P dash, and its length is L dash. Now this AP dash will give the drop across this resistance. So AP dash, we got another point AP dash and its length is L dash, and drop is VA minus VB. So we can write this VA minus VB in terms of this, that L dash divided by capital L multiplied by V naught. So here we got equation number 2 by closing this switch and applying this formula, voltage proportional to length. So here we can find the internal resistance of the battery in terms of E and this potential drop, suppose it is V. So first we will find the relation between these two and get the equation for R. So to get this relation we will take this term here, E by V will come here. Now separating the terms, R by R, that becomes equal to 1. So this is E by V minus 1 multiplied by R. So this is the relation between internal resistance of battery and the voltage across AB terminal. So here we got the first relation. If we have given the voltage drop across R, that is nothing but V. Okay, now we will find another relation for R in terms of the length of the metallic wire. So we have got this equation. Second equation is VA minus VB is equals to next we can get the relation for this internal resistance in terms of the length of the metallic wire. For this we will take this part of the equation 2, that is ER by R plus R is equals to L dash by capital L V naught. This is our equation number 2 and this is equation 1, and we are solving it for R. So divide this equation 2 by 1. Divide equation 2 by 1. Okay, we can do it here. Divide it by these two equal will come. E will be cancelled. Capital L, V naught. So after dividing this equation 2 by 1, the terms left are R divided by R plus R, and on the right hand side L dash divided by this L. Okay, L dash is the length of the wire when the switch is closed, and L is the length of metallic wire or the point AP when the switch is opened. Now we can find the value of R. Just reverse the terms and separate them. This one will come here, okay, and multiply it with this R. So this is another form of equation for internal resistance of battery. So here our internal resistance of battery R is given in form of R and the length of the metallic wires in two cases, and in the first case we got R in terms of the E and V. So this is the equation B. So these are the two relations we got for internal resistance in terms of different parameters. Thank you. अगर आपको ये वीडियो अच्छा लगा हो तो इसे प्लीज लाइक करिए और मेरे चैनल को सब्सक्राइब करिए. Thank you.